Okay. This is going to be a definite integral because we get the boundaries of integration there.
Is that u on the bottom? It's 2 and u? Or?
It's a 0. It just,
Okay.
yeah, that's the.
Okay.
I picked the bigger size so it would be easier to read, but then it doesn't always pick up. It doesn't connect a little, those little fine things like that. Okay. So now, if I look at this, here are my choices. If I let u equal x plus 1, which is what I usually want on the bottom, right? The derivative of the bottom is going to be like 1, and I got that mess on the top. That's not very helpful. So let's see, another thing I could do here is I could split it up into x squared over x plus 1 minus 2 over x plus 1, but it's still not pretty, okay? So one thing I can do in problems like this is come off to the side. Let me pick a different color. That green can be hard to see. And let me divide x squared minus 2 by, I'll go ahead and just do some long division on it. This is going to make it a little easier to look at. It's actually going to simplify it quite a bit. You remember when you do the long division, this was way back in Algebra 2 probably for you guys, you look at just how many times does x go into x squared, and then you just multiply it out. So x goes into x squared x times, right? So x times x is x squared, and then I have plus x. And if you remember, you subtract all that. So x squared minus x squared causes your x squareds to go away. And then I would have negative 2 minus x. Except I probably should write minus x minus 2 if I don't want to end up with a mess here. Because remember, we should always kind of put the biggest term, the term with the largest exponent first. So I copied it down and then realized that was not the best way to do it. How many times does x go into negative x, or negative x divided by x would be negative 1, right? So I'm going to put minus 1, so that's x plus 1. And then I'm going to subtract that term from the term above it. Let's see. So negative x, wait a second, I didn't multiply that out right. I should have said negative 1 times x is negative x, negative 1 times 1 is negative 1, and then I'm subtracting, so
it should be
negative x.
Positive x plus 1 should be your final on your bottom, right?
Let's see, the x's cancel out, right?
But you're not going to if you have, nope.
You're going to be left with
no, you're good. You're good.
Yeah, negative 1 times x is negative x. That's what I had there. Negative 1 times 1 is negative 1, but I'm subtracting all that. So negative x minus minus x is negative x plus x, which makes the x's go away, right? And then negative 2 minus minus 1 would be negative 2 plus 1, which would be negative 1. And so what I'm going to do with that is put it over x plus 1, right?
I thought that for 1 second.
Anyway, negative.
Let me turn this back on. So I'm still going to integrate, but I'm just going to integrate this instead now. What's good about that?
There's a lot less stuff.
A lot less stuff to mess with.
Also, there's no weird, like, top and bottom.
Yeah, because we could split this up and give each one of these things an integral, right?
Yeah.
I mean, I could say integrate from 0 to 2, x minus 1, x minus 0 to 2, 1, minus 0 to 2, 1 over x plus 1. Technically, and there's a dx with all this that I am not copying down, so I'm not being a good, thorough mathematician here. Okay, so if we integrate x, isn't that going to be x squared over 2, right?
Yeah.
Just do it, because that's just a normal power rule thing. If we integrate 1, it's just going to be x. And if I integrate 1 over x plus 1, if you look at x plus 1 as your u, your derivative of that u on the bottom would just be 1, and I have that already, be 1 dx. So wouldn't that just be minus ln of x plus 1, right? We all okay with that?
Yes.
Just each term separately. So dividing it out can really simplify things, make it not such a weird thing. And I got to do all that from 0 to 2. Oh, great. I'm going to have to copy this because I am not going to have room writing in this big old font, am I? 2 value there. I was going to do it in a different color, though. So 2 over 2, oh, that was squared. 2 over 2, 2 squared over 2, minus 2, and then we had 2 plus 1 was 3. Okay, so it's all that minus, before we do it, let's clean this first thing up just because it gets a little tricky. I missed this one when I was doing it because I had a wrong sign somewhere. That would be 4 over 2, which is 2, right? All that is 2. Minus 2 is 0. So don't I have 2 minus 2 is 0 minus ln 3. So isn't it going to be ln 3 minus ln 3?
Yeah.
Okay. That's the first part. Now I got to go do the second part. I got to plug in the 0 now. Well, 0 squared over 2 is 0. Minus 0 is 0. Minus ln of 0 plus 1. Well, 0 plus 1 is 1, which is 0. So it's minus ln 3 minus 0, which is, yeah. Yeah, I got all kinds of little negative mistakes going on when I did it the first time, so.
Oh, wait, but isn't the ln of 1
0.
Okay.
Yeah.
Okay.
Oh, and that's what I wrote up here. It's because
Okay.
that you needed that here to get the 0. And I had to go look it up because I couldn't remember it. I couldn't remember it when I was doing the problem either. And it was because it was in 5.2, and I looked at 5.2 during like spring break time period. Yeah, I guess your calculator could help you if you forget that, right? So we're going to let u equal x minus 1. I forgot to hit record. Du would just be 1 dx, wouldn't it? Because the derivative of x is 1. So we look at this, and if I rewrite it that way, I have a half. Wait, what am I doing the half for? I don't need to do that yet. I have 2. I could pull the 2 out front. And I got x on top. Well, that isn't working for me so well, is it? Okay, so that choice didn't work out so well. What if let's try something different. What if we let u equal x minus 1 squared? Okay, so if I take the derivative of that, I could say it's 2 times x minus 1 dx, right?
Mm-hmm.
Okay, so if I multiply that out, it's 2x minus 2 dx. Ooh, I just have 2x up there. Maybe I don't want to take the 2 out.
If we use Ashley's calculator, maybe it'll work.
Well, we're not going to ask the calculator. Here's what we can do. I can add something in. Wait, I want to subtract it first. Let me see if I can undo that. Come on, undo it. Okay. I could say I need a 2x minus 2. Why don't I put a minus 2 and then a plus 2? I'll be honest with you, I would have not known to do this because this is the one I got stuck on and had to look at the answer key on. Because I never thought about doing this. If I do that, and here's what I can do. I can split this up into 2 integrals. 2x minus 2 over x minus 1 squared plus 2 over x minus 1 squared. I kind of got to do both of these u's and just use them on each separate problem. So it wasn't a waste what I did at first. It's kind of like I'm going to have to consider both of these possible substitutions. I probably should have called one v or something just to differentiate between the two. So if I look at the first integral, I have, and both of these should have a dx on them, and again, I forgot to do it. 2x minus 2 dx, hey, that's using this u substitution, right? So this would be u du. So that, remember, that's just ln of u, right? Does that really make sense? Or y'all is nodding to
Makes sense.
okay.
I'm sorry.
I was worried.
Every now and again I've noticed, I don't know.
Oh, I forgot to turn the silly thing on. So I used the yellow substitution for the first term. I'm using the purple substitution for the second term, which I wrote in purple. Okay. So if we simplify this, I'm just going to keep up with this ln x minus 1 squared because it fit the pattern we're studying today. But this other one would be 2. If I add 1 to the exponent, it would be u to the negative 1 over negative 1, right? Because we add 1 to the exponent, then we divide by the new exponent, plus c. But that would be, we just could go substitute back. Oh, I'm going to need more space. If I substitute back, wouldn't this be a minus 2? I tell you what, Okay, now we're still cleaning up the second half here. I'm just going to keep up with the first term that we've already figured out. This is just, I'm sorry, that should be a minus 2 over u plus c, right? But what was the u I used for that second part? It wasn't the same one as I used for the first part.
X minus 1.
Yeah, so it would be x minus 1 plus c.